All right. Slowing. Okay, cool. So good afternoon, everyone. My name is Franz Allegre. I am a software consultant here in Southern Street for about two and a half years. And today I'll be talking about Phaser. So what is Phaser? Everybody knows. Um, our agenda for today is divided into four sections. There's the introduction, there's the essentials, there's the cool stuff and tools, and bring it all together. We'll start with introduction, talking about what is Phaser, what is this doing, and then a quick recap on Canvas and WebGL, and then what are the things that we need to get started. After that, we'll move to essentials. What are the essential things when we're developing a game? What are the stuff that's needed to start like developing like your full-blown game? And then after that, we'll move to cool stuff and tools, such as Phaser physics or game physics. To those who knows about the gaming, there's two types. There's arcade and ninja. And then we'll jump into balance and weapons, and then virtual joystick, then some tools that I've been using. And at the end of it all, we'll bring it all together, and then we'll have a demo game. So with all of the factors that I'll be discussing in the first couple of slides, we'll see how this goes into kind of like production kind of stuff, or like a full game per se. Now we'll start with introduction. So what is Phaser? Phaser is a fast, free, and fun open source JavaScript framework. It offers WebGL and Canvas, HTML Canvas support, rendering across desktop and mobile browser. It is developed and maintained by PhotonStorm, led by Richard Davies. So Richard Davies, one of the guys, probably pioneer in HTML5 gaming, and he's also very active in HTML5 game dev forum. So if you have questions later on that I may not be able to answer, probably something that's very difficult, then he's definitely the guy, right? And he's really responsive. Going back to the second bullet, it's offering on WebGL and Canvas. So I just want to ask who's familiar with HTML, Canvas, and WebGL. Yay. Yeah. So if you've attended my first two tech topic presentation, yeah, I've talked about that. But let's do a quick recap. So Web Canvas and WebGL, Canvas and WebGL. So what's the difference between the two of them? With Canvas, we're doing a soft rendering. So all of the rendering are done in CPU. While in WebGL, even though WebGL uses HTML Canvas, it just uses it as a window. It's not really using the CPU. All the rendering are done in GPU, or graphics processing unit. In Canvas, it uses vectors. It can also use bitmap. While in WebGL, it uses 3D elements, such as one of which is vector. There's meshes, and there's wireframes. So why do we want to choose one over the other? So the reason is that when a machine has more CPU power than graphics card, then Phaser switches it to Canvas. So let's say we have a very powerful work laptop, but it doesn't have a lot of graphics power per se, and then it would switch automatically to that one. On the other hand, when a machine has powerful graphics, let's say you have an Alienware that's specifically for gaming, not really for work, then it switches to using GPU. Note that it's only if we set the game config to auto, then that you'll let Phaser decide it. But there are times when we want to set what it should use. And the reason why we want to set where it should be used is maybe we're just targeting a certain kind of brand or specific specifications of computer. Here's like a little chart right here where the GPU and CPU is coordinating. All right, going to the next one. How do we get started? There's the download for Phaser, download link for Phaser. It can be delivered through CDN, minified version, and it can even be installed as through NPM. Right now, there's two versions of it. There's 2.11 and then 3.0. The big difference between them is how we code, but there's there's a lot of similarities in them than differences. Um, However, if I would suggest if you guys want to try it out, I would go for 2.11 because of all of its documentation, and 3.0 is on its juvenile stage, so there's not a lot of documentation and probably there's bugs out there. Um, so if you want to start on developing game using Phaser, then 2.11 would be the best. Um, what other things that we need to have? Just basic knowledge of JavaScript and or TypeScript. You could use either. And then I also would like to suggest to join the community because they have tons of example. There's a lot of collaborators on what type of not necessarily libraries, but what type of game do you want to achieve, or what type of physics or what type of like graphic manipulation do you want to achieve. There's a lot of examples out there. Um, Before we get to essentials, any questions? Okay, essentials. What's like the biggest thing, first thing that we need to consider when we're building a game? Obviously, it's the story. Like, and what are the steps that we have to consider when we're building a game? So I broke it down to 7 steps. We'll go each step one by one. So for step one, we have to outline the major storyline of the game. Think of a movie. Does it have a sad beginning and happy ending? Is it like sad, sad, or happy, happy? Just think of the big plot line of the game that you want to achieve. Is it like a zombie apocalypse kind of game? And then the second step that you have to consider is to decide what type of game it will be. Is it an action adventure, like Metal Gear Solid or Castlevania, or an RPG, or role-playing game, Final Fantasy 2 or X2 or Skyrim, or an FPS, first-person shooter, Overwatch or COD, or puzzles maybe. We could also do that in Phaser, like Candy Crush. So once we've decided the type of game and what's the story outline, we'll go now to develop the world. So what is the world of the game? Is it futuristic? Is it post-apocalyptic? Are we going to have scary sound effects? Are we going to have like a very so basically you have to think about how do you want to present the game to someone? How do you want to package it? Is it like when what's this? When Walking Dead is presented, like we already know what it is. It's dead that's walking, so we know it's about zombies. So that's how I want to think about how we want to develop the world. Step 4 would be like create your main characters. So what's your main protagonist like? Is it like someone an orphan lady who has a backstory that someone's like trying to murder her, or like is it a kid who got lost and he's trying to find his parents, you know? And are there any human villains? Is there like stepsisters, like really wicked and cruel, or are there like aliens who's trying to explode or like kill everyone? And then once we're done with those things, then now we're moving to kind of like the heart of the game, which is the flowchart of the major story. This is very crucial because this is where we want to know, or how we're going to decide how would this user win or lose in the game. Like, does he win when he collects certain things, or does he win when he kills everyone in the game? So it's kind of like that. And then once we're done with that, then we start writing the main story, the major story. Note that in step 1, it's just outlining it, and in step 6, it's writing it. This also involves the developing part, the coding part, I mean. So think about the main quest. Does your character assembles a puck, eating dots to win while trying to avoid Blinky Pinky, Inky, and Clyde? So I have a question. Who knows who are those guys? Yay. So the people who doesn't know who Blinky, Pinky, Inky, and Clyde, Those are the four ghosts that you would see in Puckman. I'd say Puck, not Pac, because the first version of Puckman is actually Puck, not PAC. And they later changed it to Pac-Man because they feel like it's more marketable than saying Puck. And then step 7 is more optional. Like, do we want to have side quests? Do we have to have NPCs, non-playable characters, and other small details? So now that we have a plot line and we have a story in our head, what's next for us? We have to think about our assets. So assets are collections of graphics, sounds usually placed in one folder that can be used as background characters or even obstacles. Sprite, there's like three things right here. There's the sprite sheet, and background. Most animators are getting confused between sprite and sprite sheet or texture atlas, and I'll break it down for you. Sometimes they got confused between sprite sheet and sprite. A sprite is something that is in your world, while a sprite sheet is where all of the texture or where all of the faces or like the states of your sprite can be. So here on Phaser, sprite is defined as a 2D bitmap graphic object that can be static image or an animation that is integrated into larger scenes. You could think of it as your NPCs or your characters or trees, while the sprite sheet or texture atlas is an image containing the collection of smaller images, and it's actually packed together to reduce the size in the memory or the loading time. And then the background is just a static image, or usually the first layer of any animation of game, and can either be created using texture atlas or just one big image. So to the people, and has anyone played Sims? Okay, so like you would notice that there are some things that's repeating right there. It's because they're just using texture atlas. They just got this one image and they try to like spread it out or reuse it everywhere. So that's how texture atlas is being used. While the sprite, the sprite sheet, the sprite sheet is being used when a character is being moved. Like in this case, this Phaser, we call this guy as the dude. In this case, the dude has left and right animations, but obviously we can't see it yet. We have to animate it. So we're settled with our story, we're settled with our assets. What's next for us? What should we do? How are we going to start doing it? We'll go first with the animation. Why is it important to know about the animation? Because without the animation, we wouldn't know how our character will move, or how our main character will move, or how other characters in our world would move. Animation is a dynamic medium in which images or objects are manipulated to appear as moving images, like the flip book right here. But in Phaser, in animation world, the animation means slicing or mapping the sprite sheet using coordinates, height and width, and representing them as if they're moving. So right here, dude is, you can see dude right there, but later on in the game, we'll be able to see how dude will move. I have an example for animation, just to show you. Okay, let's just pull in my assets real quick. Animation demo. Can you guys see? I have a female zombie right here. It's just a free sprite that I saw online, and I think it would be cool to use it as example. If you can see right there, this is just an example of sprite sheet of the female zombie. But by looking at it, you know how it would move, and the thing that we have to figure out is, yeah, how can we do this in Phaser? So I have an example right here. For now, don't think about the other codes right here because I'll explain it in the Phaser states. But what I want you to look at is this JSON TP array or texture packer array. It's one probably flavor JSON that's built or made for slicing and mapping, a sprite or a sprite sheet. I mean, so if we show this, but I'm just like looping through this image. Any questions for the animation? Okay. So that's how the animation works. Like in this case, this JSON is just looking where it is, like where's the X and Y and what's the height and width, and then it just goes from the first object of frame and then go down to the last one. All right. Okay. So where's my presentation? Yeah.
Why does it have like separate timelines?
Because in my tool, the tool that I've used, I have like different images, and I put it there. I'll explain it later on when we hit the tool section. But basically, what I did was I have different images of zombie, and I tried to compact it into one, and then I was able to generate the TP array. But I'll demonstrate it later on. Okay, so where is my presentation? Sorry. It's here. Okay, so we have the story, we have the assets, we have the animation. We know what to animate. We know which ones should be animated, which ones should not be animated. What's next? Should play. To play? Yeah. So, and it doesn't do anything. Anyway, yeah, you could think of like it's playing. Music and sounds are equally important to visuals or graphics when it comes to developing game's atmosphere. So think of your first impression when you hear J.S. Bach's Toccata and Fugue, or even Beethoven's Symphony No. 5. Like it gives you that sort of yeah. I didn't know why it's not playing, but it should play and it should sound like dun 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 kind of thing. But yeah, I feel like you had some chills right there when I did that. But, so we have to think about the audio as well. Like, how are we gonna mix this audio to the world? We don't want a happy-looking game and we have like a scary sound that's involved with it. You don't want to have like a Candy Crush and then it would say pew 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 whenever we do something. We have to make it associated. Arthur told me when I'm presenting this to him was, with game development, there's three actors. There's the music, there's the development, and there's the art. And with game development, those are the three factors that we have to orchestrate. It's not just the big difference between working in game development and working into like an ERP is that with ERP we only care more about the codes, a little bit on the UX. Obviously, we have to know how the user would feel it, but not so much in the audio. Well, on game development, we have to make sure that those three factors are orchestrated or mixed together with equal focus. Like we can't just let ourselves be inclined with just doing the audio or like the art. We have to do it with the coding as well. So going to that, now that we know those four things, story, assets, animations, and audio, we'll now go closer to Phaser. So what are the states in Phaser? So when I say states, these are the things where you could hook up or things that should always be present in your Phaser game. You could think of it like init and destroy in JavaScript. But in Phaser, there's four states. There's the preload, where you load all of your assets. There's the create, the init function, or initialization of the game. And then there's the update and render. It's the core game loop. And right now, like presenting it right here in words, it's not really helpful. So I have an example for that. So, where is that Phaser states? Okay, Phaser states. Expand you. Yeah, I think I can expand you. So here we have the preload. sorry. Yeah, is that good? Okay, so we have like on this file we have four main functions, um, which is the preload part, the create part, um, update, and the render. We usually start coding with just initializing that we're doing a phaser game, and then we're passing it the different configuration. And in this case, I'm passing height and width. Yeah, width and height. I mean, and then I'm telling the phaser to just use canvas. So going back to the first slide, where I talk about WebGL and Canvas, I'm restricting this file to just use HTML Canvas. I don't want it to use WebGL. But I could tell it to use WebGL, or I could tell it to use Auto, where it would switch manually by itself. And then just title, and then we declare the four main functions, and then just global variable. For the preload, the preloading, the best practice for it is to just preload all the assets. At this point, there's no controllers, or like there's no initialized functions yet. There's no controllers or initialized controllers yet. It's just we're adding the image, audios, animations to the game, but we're not using it yet. We're just putting it there on the game. You could think of it like, what's the best example for it? We have a workstation, and we're just putting all the Play-Dohs next to us. We're not doing anything on that, on the preload stage. And then we go to the create function. So it starts in the preload and then goes to the create function. With the create function, we create the world. This is where we're going to use those Play-Dohs, those sprites that we've added earlier, and make sure that they're tangible in the game world. So in this case, I've added, I've preloaded an image block, and then on create file, I make sure that the box is actually a sprite that I can manipulate on my game. Preload and create are only called once, because they're kind of like the initialized functions, while the game core loop is getting called 100 milliseconds every time, because this is where we have to determine, like, should it go forward, should it go backward, or should it animate, basically. This is where we put it there. And there's the optional part, which is the render. The render, right now, it's mainly used for debugging, but before it can also be used up until now for additional or post effects. Let's say someone, you blast a spaceship and you want to add some sort of shadowing after the blast, then you could add it in the render. But right now it's just being used for debug. For us to see this like in a developer's perspective, I would open the sample and I would open the console. The console didn't show up. There we go. Let me expand it. Come on. And I'll just reload this so we'll be able to see it. So you see right here, it starts with the preloading and then create, and then every 100 millisecond it calls update, render, update, render, update, render. Until, well, it's not until. The update and render checks for everything that we're doing. At least that's the code that we've added. Because if you see in our code, we've said right here that if the cursor got pressed left, then we do something. If the cursor got right, got pressed, or is down, then we do something. So in this case, we're just moving that box. Also, it's a good thing to note that the phaser can also be used on mobile development. So it's cross-platform. You can develop it on your desktop and just I don't know, deliver it on different devices. It will handle those shifting for you. But you could also manually handle it by yourself. Okay. Let's go right there. So, any questions about the states? Yes.
I noticed that on line 32, you gave the sprite a name. What benefit? Do you use that for anything?
Yeah. So, when you have a name on the sprite, sometimes I reuse. It depends on what you want to do. There are times when you want to reuse the sprite every time. Like you could do a loop and then add a lot of sprites at the beginning. And you want that to have like unique identifier. And instead of like adding different variables, that sprite 1, sprite to sprite 10, you could just say var sprite, but give them individual names. So it's a unique identifier for them.
So is there a way that it prevents you from reusing a name, or if you gave it a sprite a name that another sprite already had, it would like overwrite to?
It would overwrite. It's kind of like the same way that we do it in JavaScript. Like when we reassign it, it's the same thing.
Was there a way later to use the game variable to find a sprite that you made?
Yes, yes, there is a way. The physics, we'll talk about that in the third section of this presentation. But yeah, any more questions on the states? None, going once, going twice. Okay. Go back to, now we're going to go to the cool stuff and tools. We'll start first with phaser physics, and I like to talk about this because there's a difference between the physics that we do in class and like the game physics, although they have like similarities. And I'm not gonna dig into the mathematics part of this, but because I didn't review that one, for full disclosure. But in phaser, there's actually 3 types of physics that can be used. But there's the arcade physics, there's the ninja physics, and there's the P2. However, they just started deprecating the P2, so we won't be able to use that anymore. It's not being used by a lot of people. So the difference between the two of them is like in arcade physics, it's just axis aligned bounding box, or AABB. What that means is if you're in a Cartesian plane and image A hits the X of image B, there's already a collision. Like it would trigger a collision. That, oh, okay, we already know that there's a collision, which means that there's no static, there's no moving. There's no static, there's no rotation moving, or there's no angles that can be computed. It's just X and Y. Like when your boundary hits my boundary, then that's it. It's high speed it's very high speed and cheap on computation because it just checks if our X and Y's are like in the same area, and then we already got like a hit or a collision. While for ninja physics, who's familiar with ragdoll physics flavor? Yeah. So anyone who's not familiar with ragdoll, before, think of the time when Lara Croft was introduced, or I don't know what's the best. PS1, I would think. Game developers are trying to figure out what's the best way to emulate death. When, for example, when your character dies on a staircase, or when your character dies on a vehicle, you don't want them to die like a block and just go down like that. Like it's, like, yeah, we could say that, hey, that character probably is in rigor mortis, and then it just died while it's in rigor mortis. I'm sorry, I'm getting dark because I haven't had my coffee. I'm sorry about that. So these game developers had they introduced their ragdoll physics flavor, wherein when this character dies, it starts to compute all the angles, how it should die. That's why it's called a ragdoll. Like when you pick it up and it just falls down naturally, the way a human or a doll would actually fall into the ground. In Phaser, there's this ninja physics. It's a ragdoll physics flavor where you could also enable AABB, but it's more smoother than AABB from arcade physics, and I'll show it to you later on. With ninja physics, there's a rotation, and it's non-static. What that means is it computes your angles and your sides if there's actually a collision. Why does it matter? With AABB, when your other image is transparent, it doesn't check right there. As long as there's X, as long as you guys hit the same X, it says collision, even though there's no item right there. Well, with Ragdoll Physics or Ninja Physics, it checks, are we in the same angle? Am I actually hitting this item? Is this item not transparent? Then that's the time that it would say, okay, there's a collision that happened. The downside of Ninja Physics is that it's a little expensive on the memory. But with all of our machines right now, there will be not a lot of difference unless you're running Phaser into like a really, really slow machine. Then that's how you would notice like how expensive Ninja Physics in game development compared to Arcade Physics. So I'll go to the demonstration. Wow. So this is the Arcade Physics demo. Let me just close these things. Yeah. So with can I expand this? Yeah, I can expand it. Yeah. You guys see it? Yeah. Better. Yeah. Sorry. Now I can't resize it. Anyway, with Arcade Physics, it's just checking the X and Y. So in this case, when I move this, it just checks it. Okay, there's already a collision that happened. But like it doesn't necessarily mean that I hit that item. It could also mean that I go over that item. So there's the collision part. It's not a good one, but it's the fastest when it comes to animation. Like if I scroll back and forth, you would see that it's a little bit, it's the right term, choppy. It's a bit breaky a little when you're looking at it. So that's how the Arcade Physics. And when's the best time to use this? The best time to use this, let's say you're making a game for a shooting game. Well, not shooting because it's not accurate. But you want like a spaceship game, and you just care about how many items does the bullet hit. That's one thing where you could use it. Now let's go to the Ninja Physics. Physics.1. Loading. This one, I did enable the debugger, so you'll be able to see what's happening. If you could see, like it fell like smoothly. The reason why it fell because we're not really limiting it to X and Y. Although if you look into the codes are pretty much similar. I'm putting it to 100 and 300 and 400 and 300, but this one's using Ninja, while the Arcade Physics is not using Ninja. They're in 10 and 300, and then 400, 300. Are they the same? I hope they're the same. Yeah, they're the same. But the difference between that is this one fell, like it fell to the ground because it's not limited to the X and Y Cartesian plane. And if I move this guy, like you'd see like you see how it looks like a ragdoll when you drop it, when I drop it? That's how the Ragdoll Physics is, or Ninja Physics in Phaser. So before I move, any questions regarding to physics with this Ninja Physics? Not that kind of physics, please. Yeah, I'm not prepared for that. Actually, there's another example that I have created. There's a Ninja Physics demo too, and it didn't load. My laptop doesn't like me very much, so forgive me. See right here, if this is an AABB, it wouldn't compute for that angle. It would just say that it would just stop the moment it hit this area because it already hits the y and the x-axis of the triangle. So that's the ragdoll physics compared to AAPB. Questions in arcade physics? Yeah.
For the ragdoll, but is it difficult to allow rotation with ragdoll physics? Like the cube doesn't rotate when it's an angle, but
yeah, you can allow that. There's actually an example on their website wherein they have this truck. It tries to trace the whole terrain of the road and the whole mountainous area. It's really cool, but there's a lot of like coding that's involved with it. With this one, I just showed like the bouncing part, but definitely you could do that with ragdoll physics though, because it computes all the angles and sides. Yes.
I mean, I think you didn't have anything for this episode, but presumably there's a way to, give things different weight, for instance, so that
there's the bounce that we're going to talk next. That can be done using the arcade physics or the ninja physics. Depends on how you want to visualize it. That's when you're going to add like a weight kind of thing. And you would notice like if it's going to be bounceable or not bounceable. Any questions? Yeah.
Could you simulate something with a joint, like two things connected by like bend?
Two things that would bend the middle.
You have like an arm that could like bend.
Yeah, that would be a great example, but I don't have it at the moment. I could probably do it later on. All right. Now where's my presentation? Oh my gosh. I think I just closed my presentation. Sorry guys. Okay, let's go to cool stuff. Now we're moving to bouncing weapons. I left this blank because I want to demo it more than talk about it. But when you say bounce, it's just like how ball bounce. Weapons is like how do you use the weapons. And in Phaser, there's a pre-built weapon library or classes, and it's only used for bullets. So I will show that to you guys. For bounce, where's that bounce example that I have? Okay. I don't have, oh yeah, I do have bounce demo. Okay. Yeah, so this is the bounce demo. Who's familiar with pinball? Pinball, or those games. Oh my gosh, it's not reloading, sorry. Okay, there we go. So here you see the star. I could move this one because it's a movable sprite. But the moment like that got a little more, come on, there we go. That's the bounce part. And I could make it in such a way that when it bounces, it only bounces once. So it would look like it's really heavy. Or I could just remove the bounce so we would say that, oh, that item is actually heavy. In this case, I made it like a rubber ball, so it would actually bounce all of the boundaries of my world, of this world, not my world. And then it would look like it's getting that velocity. So that's the bounce. Later on, I'll show you how it's being used in a real game. So we have that bounce, and then we also have, so to set up the bounce, we'll just have to say what physics we wanted to use, and then we just have to set that bounce on that sprite, and that's it. Yeah, the platform says immovable, but it's not. Oh yeah, it's immovable. This should be false. Yeah. So what on my code, just to explain a little bit, I started what what physics I'm going to use. I've enabled the cursor keys. I've added the sprites for star and the platform, and then I've enabled the platform and star to on the physics so that they could use whatever the game physics applies. And then this immobile, I can't remember why I put it there, but this is the one that gets the star body moving. So this star moving, bouncing around, and then this just tells that if it hits the world bounds, our screen, then it bounces up somewhere else. And then for the weapon, so again, for the weapon, they only have one weapon under library, which is the bullet. So for the bullet, yeah, I've put a lot of documentation right there. For the bullet, I just put all of this attributes, set it up right there, and what it does. Kill world bounce is that when it leaves the world, the bullet is not alive anymore. So for us to see what exactly I'm talking about here, oh yeah, I've also set the fire button to be the space bar. I have a lot of instances. Close the right hand. Come on. Yeah. Oh my gosh. Sorry. Why is this not moving? How can I zoom this? There we go. Okay, so in this case, I have this space. It's just like ordinary sprite that I have to put like up and down. But the bullet one is this. It has like variants and the sprite that I use for bullet. So you can change pretty much what bullet you want. If you want the stars to become the bullet, then you could just change the sprite for bullet. But the way it was being scattered is handled by the bullet or the weapon library, not library, but the weapon class of Phaser. Yeah. Okay, so that's with weapons and balance. Any questions before I move to the other one? So I have this. Where's my presentation? Yeah. Virtual. I just found out that there's a package for Virtual Joystick, and I tried playing it on Sandbox. However, playing it locally, the package is paid. So consider purchasing the package. However, I have an update. There's actually an example that we can show. Oh, no. Where's that? Oh, well, I told you my laptop doesn't like me. Okay, let me just... No. So with Virtual Joystick, I picked this example because it's kind of similar to what we did with bullets. But this one, instead of using the keyboard, it uses this Virtual Joystick, and then it shoots 3 types of bullets. So there's the one that I showed earlier, and then there's this guy, and then there's this guy. The world looks like it's moving, but it's not. It's just like we have an animation behind it. That's why the animation is important too when it comes to developing your game. Note that this can also be played on your phone. It's better to be played on your phone because you'll be able to have to feel like you're actually holding a joystick or like a console, a game console. So that's with Virtual Joystick, and I should probably purchase it, but who knows? I may or may not. I'm cheap. So we'll go now to tools. Okay, with tools and resources, again, as I said earlier, the Phaser docs really vast. There's a lot of information right there that we could use, and it's really well documented for 2.11 or 2.x. But for 3.0, there's not a lot of documentation yet, so I wouldn't suggest checking that out. But if you really want to play with it, there's a sandbox, for Phaser, and if we click that link, it gives us this template where you could do a single, use this sprite. This is where you put your code, you put your create, your update, and render file, and then we could display it. Right now, it just shows dude, the one, like when you start learning it, it's the dude is it's a free sprite that comes with Phaser. So now where's that? Yeah. It's annoying that I have. Come on. Yeah. So and the other one is Leshy Labs. This is for sprites and sound effects. I wonder if I put if I turn out the volume right here, it would actually make some sounds. I don't want to. Oh yeah. Let's see. So with Leshy Labs, this is another thing that I've been using for game development because it gives me the spreadsheet tool. So the one that Luis is asking earlier, why do they have different names? If we go to my downloads, I think I have that wheel, the PNG. I have this female. It has oh, it's really small. And I have different images right there for the sprites. And let's say we want to get this dead. So when you have this separate images, you can just drag and drop right there, and then just change the file name, or the file type to TPRA, and then copy paste this whole thing into your Phaser. Then you could animate already. Well, obviously you also have to download this sprite, but other than that, it's an easier way than to manually plot it by yourself. And the other thing about this Leshy Lab is they have this SF maker where you could, there we go, sounds are there now, where you could actually create sounds, and they have pre-designed sounds, but you could mix and match, say loss, and then arrange it, think of retro stuff. And then aside from that, there's also the Game Maker. It's a world designer. I'm pretty sure a lot of people knows or may or may not know about it. But what the Game Maker does, it gives you a way to design your world. You could download it. I think it's free. And then you could create your world in sort of simple designs to complex designs specifically for mobile or desktop games. Now that we're going to the demo, I'd like to show you the game that I built using Phaser. And where's that? Game demo. Yeah. This one's using 3.11 when I started playing with 3.11. It's not using the 2.0, but the sounds are very crappy because I'm not good at music. But the game is there. As you can see, we have this animation. So that's Dude, how Dude is being animated. Basically, we're just shifting the sprite sheet. And then there's also this, let me reload it. Look at the stars. They're shining down on you. No, I'm kidding. They're bouncing, and then if you look at it, they're this one's lighter than the other star, obviously. And then when we pick them up, there's a collision that happened. Whenever we picked it up, there's a collision. And then when we jump, we get a collision. And then I want to show you another thing, which is with the bounds. So when I've collected all of these stars, then I introduce two bombs to avoid those bombs. Now when we hit that bomb, it triggers something. There's a collision. See that? Like, it's not really hitting the guy, but it's the dude, but it's really hitting. But it says that it's already dead. The reason for that is with the bomb, I use an arcade physics. It just checks for my AABB, my X and Y, even though it's not really there. But for stars, you could see earlier that I hit the star. With that, we have some time. I'd like to ask two volunteers to play against one another. Whoever gets a lot of score then wins a Starbucks gift card. Okay, V?
Oh, no,
okay.
So it was kind of hard to tell when you were jumping between platforms, but is there an upper bound on how high you can jump?
Yeah, you could set that up during.
Did you set it you only have like platform height, or if you build it up, what you keep?
I didn't set it up that way. I just use whatever is in the default one. But in this case, I think, yeah, I did set up the height, but it's being calculated like when I'm jumping from one platform to another. It's calculating if I'm hitting that maximum height. But when it comes to platform's height, I don't think there is. So anyone who wants to try? Okay, another one. Okay, Luis.
What's the highest score?
There's no higher score. Before that, I do have like FF. There's a cut along the lines. I would like you guys to pass in, not the paper, but just the sequence. Okay. You're gonna die.
Nah, I'll live forever.
No, you're gonna die.
Oh, I can't make it.
So 290.
Hey, that's cheating. I was off of that.
Nice. Good try. Good try. Yeah, just argue.
Oh no, it's where the up and down are. Oh. Not loving this. Just gotta bide my time. Ah, boo.
The next one. So, yeah. Well, yeah. Once you're done with that, okay. Any questions regarding? Not. I don't want to hear that sound again. Any questions? Any more questions?
Have you thought about, like, for the jumping part, like maybe every 1 out of 10 times you just like tripped, like half?
Yeah. Well,
or something like that?
yeah. I have to introduce a different sprite, like when it's tripping, because I don't have a sprite yet. Like how would I present if it's tripping or not? I only have like running left and right. But yeah, that's a good idea. I could probably add it up to the game itself. Yeah, but definitely that's something we could do. Yes. I don't know. I have to add more. I have to add more stuff into it because like I haven't had a chance to explore the preloader. Like, you know, when you open up a game, it says like Sega or like something. So I have to add that in some menus and high scores. But definitely something that I would have to add later on. Any more questions? Well, this time I'd like to call on Mr. Arthur because it would help me like. Right? Yeah. Just.
Is that what's happening?
Yeah.
Wait, let me make it.
Any more entries right there? Yep.
What was on it?
2.
First winner is Tommy.
What?
Oh, hey.
What company does he work for?
I added it.
Robert Winger.
Oh. All right, congratulations, guys. I'd ask you to like just probably leave those other paper for feedback. I'll pick them up later on. But thank you guys for attending. I guess that concludes. Recording.